Okay. Hi, everybody. This lecture is an introduction to the course of computer vision. This course is intended to be with a practical flavor without any depth in discussion of the background of machine learning algorithms. During this introduction, I shall try to familiarize you with this course. What is computer vision or what is machine vision? What are the basic competencies of the computer vision engineer? And the basic areas of applications for computer vision. At the beginning, we shall try to define computer vision and its relationship with similar artificial intelligence subjects. Precisely, as you see here, computer vision could be defined as a subject where we study the images, acquired images, and try to extract data from them for the purpose of control of a process or an activity. Although this definition is very short and precise, but I think it is very sufficient to tell the listener that the computer has a vision as the human. It looks inside the image and extracts information and makes patterns of elements inside the vision, the image, and makes use of this information in order to make decisions. So the computer, as the human, looks inside the image and try to find information or to conclude information laid within the image. About the position and relation of this science with relative artificial intelligence sciences, it is sometimes, and in most of the cases, it is considered as a discipline of artificial intelligence. Of course, there is a justification for that. This is because the activities of computer vision engineers is not to master the art of acquiring images only, no, but it is more deeper than that because it is related with the application of different algorithms and methods in order to process the images, in order to analyze the images, in order to make patterns of the components laid inside the image, and of course, at the end, to make use of the extracted information for the purpose of control and quality assurance and other applications. So some of them, so I want to say, in other words, that this subject includes the application of deep learning and machine learning algorithms, especially when it comes for measurements and for pattern recognition or pattern matching. Some other engineers consider this course as a course at the borders, at the intersection of artificial intelligence and machine learning. Anyhow, if we accept this definition or other definitions, this doesn't change the fact that this science includes the applications of machine learning and deep learning algorithms. And knowledge of these algorithms in a given depth is essential for computer science engineers to practice their activities. So precisely when we talk about the basic elements of machine vision or computer vision, we can say that it is, of course, acquiring of the images, then processing or screening the images, and then it comes to analyzing and quantifying the things and making use of statistical methods in order to identify and the presence of some particles in the images and the number of these particles and their specifications and patterns, etc. Yeah. Concerning the application areas of computer vision, really, as broadly speaking, we can say that quality assurance or quality control may be one of the most important and wide areas of applications there. The computer engineer writes the programs which facilitate to explore the features of the images, and depending on that, these features are quantified at the end and used by the computer to compare them with a standard reference values in order for the computer to make a decision. Yeah. So as mentioned here, it represents the largest number of machine vision applications nowadays. And of course, there we can carry out the inspection of the images and make decisions about them. But it is not limited, the activities is not limited, the application activity is not limited to quality assurance only. Of course, we can find the area of sorting or classifying the elements, particles, which exist within the image for recognition and matching, and also machine vision is widely used in material handling and assembling activities in the factories and robot guidance. Suppose you have, for example, a motor which is going to be assembled in an automatic line. And the robot is required to bolt, let me say, 50 bolts at different locations in order to fix a cover on the motor, for example. So existence of a cam there, I mean, we can use the acquired image here to count the number of bolts which are fixed or which are used to fix the cover of the machine. And then you compare this number with the required number. And if it is equal to, for example, to the preset value, which is 50 bolts, so everything is okay. But if there is something missing, so there will be an alarm, and probably the robot, or because of unforeseen reason, one bolt or more than one bolt are not fixed in place, and this means we have to revise our activity there. Okay, so the other area, as I mentioned, of applications is sorting. Here we classify the particles inside the image and categorize them to different shapes or different objects. Yeah. Also, of course, there are many other application areas, but it is not the place or time to discuss them in detail. But for an example here, I am giving you an example how computer vision is used in automatic cars where human intervention is not allowed. And the humans just only supervise the moving car, and the car on its own must drive all the way and carry out all required activities alone without intervention of a human. This is nowadays is an important issue which is developing day by day. In such high-level industry, of course, there are many other various artificial intelligence systems applied. But one of these algorithms which applied is the algorithms related to computer vision. The camera, the cam there in the machine, or the system of cams, if there are more, must recognize all the objects and the road signs and all obstacles which the car faces. And it has also to analyze the captured images, create a three-dimensional version of it, consider the features of the acquired images, of course, and decide to take an action to stop the car or to continue moving or to decelerate the motion or any other option of decisions. This is one of the clear important applications of computer or machine vision. Okay, when it comes to talk about the computer engineer. Of course, I mean here computer vision engineer, not computer science in general. So this computer vision engineer must own specific competencies in order to find a specific job related to his specialization. He must be ready to apply and understand supervised and unsupervised machine learning as part of computer vision tasks. Moreover, because all of the work done by the computer vision engineer is by the computer itself. So the computer vision engineer must master a programming language and more. But at least he should master one language as a minimum and one or more other languages as supporting languages. Of course, in order for this engineer to find an appropriate job, he must have some experience in machine learning algorithms, and in addition to that, of course, as I mentioned, languages. Concerning the languages, there are many which could be used for this purpose, but they are different, of course. They are different from each other, and their possibilities are different. Some of them have very limited functions and are specified for learning purposes or for beginners only. And other languages are comprehensive and could be used in order to process and analyze and implement any algorithm related to this topic. Of the recommended languages are Python and JavaScript, MATLAB, LabVIEW, OpenCV, Sklearn, C++, and others. And here it comes to the personal favorite and the background of the engineer and which language he prefers to use. Although there is difference between these very specific languages, and for this training course, we shall apply LabVIEW as the programming languages for the following reasons. One of the most important reasons for that is that the computer vision engineer must understand data flow programming. A programming feature of this that models a program as a directed graph of data flowing between operations, and of course involves implementing of data flow principles and architecture. This specific property is included in LabVIEW clearly, and it is one of the basic foundations for LabVIEW programming. But this is not the only reason in order to select LabVIEW. Really, LabVIEW is a graphical language. It is different than Python, for example, or C++. Here you do not need to remember columns or semicolons or different types of brackets or remember different functions to be used. Here everything is given to you in libraries, and these libraries are arranged to have different palettes, and each group of palettes is used for a specific area of programming. Of course, as usually we know, in LabVIEW we have a front panel page and a block diagram page. And the front panel page is dedicated for the inputs to the program and for the, which is called the controls here, and another page which is, sorry, it is dedicated for the inputs and of course to show up the outputs in terms of graphics usually, and the other page which includes the code or the program. LabVIEW generally includes a very huge library which could be used for computer vision. At the beginning, they used graphics and sound library. This is really a precise and limited library with limited functions, but they have the vision module and they have the IMAQ library. IMAQ, which is image acquisition library. There exist more than 500 functions which could be used for this purpose. You can use them to solve any complex problem. And moreover, in LabVIEW, for quick programming and analysis, they have designed what is called the vision assistant. And they have also designed the vision acquisition express virtual instrument. These two tools make it easier for not a beginner, but for a practitioner, for a practical engineer to use them very quickly in order to carry out any investigations. And for example, when using the vision assistant, you can convert the script to a LabVIEW program, and sometimes you can mix between both. So you can have a block of the vision assistant with the already carried out investigations and programming, and you make use of the inputs and outputs and connect it with the external elements to have a LabVIEW program. And concerning also the image or vision acquisition express virtual instrument, it really makes it very easy for the user to carry out imaging very quickly without using detailed additional blocks which are normally used in order to acquire an image. And both of them, the vision assistant and the vision acquisition express VI also are integrated and could be used together in a complete program. So as you see, there is a huge work really done by LabVIEW, and there is a sufficient literature found and number of examples attached so that one can carry out any required vision activity. What are the applications of computer vision we have? As I mentioned, one of them is I said, the quality assurance or quality control, or generally also it could be shown as defect detection. The other area of application is then the measurements, metrology, where you are supposed to measure the distances, to find the center, for example, of mass, to find the midpoint between 2 points, to find the center of a circle, of course, measurement is a wide range of activity also, but here also measurements could be done by using pixels as a units of measurement, or you can convert the pixel values to a natural engineering values also. Assembly verification also, intruder detection, screen reader, code and character reader, as it happens with the barcodes, for example, one-dimensional barcode or two-dimensional barcodes. This is also included within the activities of machine vision. And at the end, computer vision with robotics and bin picking, and so on. So as you see, computer vision as a science is mature, and it is contemporary, and it is included in contemporary control and engineering issues in parallel with new technologies of machine learning, deep learning, and artificial neural system analysis. I hope that this lecture has given you an insight to what we mean by the computer vision, what we mean by computer vision engineer, computer vision programming essentials, and application areas of computer vision. Thank you.